Hello and welcome to this video on trigonometry word problems with right triangles. These word problems will have a description that we're going to analyze and then try to draw a diagram and then use the diagram finally to answer the question posed in the word problem itself. And we're going to be working through 5 different examples of various types of problems that you could encounter. Our first problem states that a person located 4 miles from a rocket launch site sees a rocket at an angle of elevation of 32 degrees. At that moment, how high is the rocket above the ground? So we want to first underline the important things. So we know we're 4 miles from a rocket, and we have an angle of elevation of 32 degrees, and we're looking for the height of the rocket above the ground. And then we also might want to nearest tenth is going to be important for our final answer. So the first thing that I would want to do is draw a picture of what is happening in terms of like what it might look like with a right triangle involved. So I could start by just drawing a right triangle first. And angle of elevation is usually representing the angle kind of looking, if you're looking straight ahead and then looking upwards, that's elevation, like the elevation of a mountain is from the ground up to the top. So that means that our 32-degree angle is this angle right here. And if the person is located 4 miles away, that means that our bottom side of our triangle is going to be 4 miles right there. And lastly, our question is asking how high is the rocket above the ground, meaning that our side over here is going to be x. So the first thing we need to do is figure out what trig function we're going to use to solve this now that we have a picture of what is going on. The x is the opposite side, and the 4 is the adjacent side as our two important sides. That means that we're going to be using tangent. So I would set up my equation first as the tangent of 32 is going to be equal to opposite, which is x, over 4 adjacent, and we have an equation set up. So now we're going to go through our steps to solve this algebraically. So I would multiply by 4 on both sides first. So I would have 4 times the tangent of 32, and then x over 4 times 4. And that would be able to, we did divide out those 4s so that 4 tangent of 32 is equal to x. And then we would grab our graphing calculator to determine the answer to our question here. And we have 4 times the tangent of 32 as our answer. And remember, you want to be in degree mode by just clicking on the mode button, clicking on the mode button and making sure your third option is in degrees. So make sure you do that before trying any of these problems on your own. So 4 tangent of 32 would be 2.499. Rounded to the nearest tenth, that would mean that we have an answer of 2.5. And this is in miles. And that completes word problem number 1. And we can continue on with our practice into problem number 2 now. So in this problem, we see that an airplane approaches a landing strip with an angle of depression of 12 degrees. So we'll need that 12-degree statement. Altitude is 20,000 feet. And we want to find the distance on the ground that the plane will need to land. So if we have our plane here at this point, we are flying this direction to the right, and our angle of depression would be represented by that hypotenuse side right here. So we have angle of depression is kind of that angle, and it is 12 degrees. And we're flying at 20,000 feet. And we can label that as our altitude. and we want to know the distance on the ground the plane will need to land. So we're trying to figure out like what the distance is. So there are two ways you could do it. You could look for this x value up here, or you can make kind of a rectangle out of what we have so far. So then this angle would be 78 degrees. And you could say, well, this side is also 20,000. And then you'd be finding this x. Doesn't make a huge difference, but in this case, we'll just use our original diagram here to solve our problem. And so now we're going to find x. So similar to last time, now we have tangent of 12 equal to 20,000 over x as our function. We have opposite over adjacent. So now we have to solve this equation for x. So we're going to multiply by x on both sides first. So we would have x times the tangent of 12, and then 20,000 over x times x. So that means we can cross out the two x's over here. They divide it out. And so we have x tangent of 12 and then 20,000. And then we'd have to just divide by the tangent of 12 on both sides, so that our x is equal to 20,000 divided by the tangent of 12. And we can grab our calculator again to solve that answer. So we are putting 20,000 divided by tangent of 12 in our calculator. And we get 94,092.6 feet. We are rounding to the nearest 1,000 feet. So that would round up to 94,093 feet. Actually, well, round to the nearest 1,000 feet would be 94,000 feet. So we can say our answer is about 94,000 feet that they would need. So give that in terms of feet is maybe a little harder to understand than miles. So that divided by 5,280 feet. So it'd be about 17 miles if we're going to go down to 12 degrees that the plane would have to then start its descent at that point. And that's what we've determined in this word problem. So that wraps up problem number 2. We have 94,000 feet ended up being our final answer. And now we'll move on to problem number 3. Okay, so we have a driveway in this problem. So the driveway itself has a 15-degree grade. It's 40 meters long. We want to know the elevation or how much the driveway rises. So the picture would be a driveway kind of rising up to a house. We know that the driveway itself is 40 meters along the road, and we have a 15-degree grade, which that's kind of how, what the elevation you're going up, like what percent grade the hillside or the driveway is in this case. And we are looking for how much it rises, which would be the x value on the other side, and that's going to be in meters too. Now that we have our diagram drawn to match our word problem, we want to use sine, because we have opposite is our x side and our hypotenuse side is 40 meters. So that we now would have in a function of sine of 15 degrees would be equal to x divided by 40. So I'm going to multiply by x on both sides, by 40 on both sides of this equation. So we're going to go up by multiply by 40, multiply by 40 on both sides, so that our final answer we can put in our calculator would be 40 times the sine of 15, And we can go to our calculator now. 40 times the sine of 15 equals 10.35. Round to the nearest tenth of a meter, we can round that to 10.4 meters of elevation change. So that is about 30-ish feet if you're thinking about it in terms of American units. So rising 30 feet is a pretty fair amount for a driveway up to a house. That would be a pretty steep driveway. And that wraps up our pretty straightforward problem number 3. Moving to problem number 4 now, out of 5 total. We have a very different sort of problem now in number 4, because we now have a person in a lighthouse 25 meters above sea level. We have something that's 800 feet away, the boat, and we're trying to look for the angle of depression. So if we want to think about how to set up this problem, it's going to be a little bit different. So we have a person kind of up here, kind of at this point. That's where they are at the lighthouse. So we could say like this is point L for lighthouse. And that person is 25 meters below, above the sea, or above the kind of part of land they are near the sea. And so they are going to be looking out into the distance like that. And they're saying the angle of depression to the boat. So we can say that the boat is down here at point B, and they're looking straight at that boat, like so. So if we're talking about where the sailboat is, so this distance up here, kind of horizontal distance, is 800 feet. Oh, well, that's doesn't agree in units. So we'll just do a little conversion real quick for this problem, since they're different units, so we don't want to have everything in different units. So there's about 3.3 feet per unit per meter. So if we do 25 times 3.3 feet, we could change that to 82.5 feet above the ground. So let's do that now to have everything agree with each other. 82.5 feet. So now that's on track now. So this is 90 degrees, since that's kind of straight out and then straight down. And what we're really looking for is that angle right there. So that's going to be our unknown theta right there. So our goal here is to find what that angle of elevation is. And if we know that this distance on the left-hand side from we call this point G, or the ground, this distance is 82.5. That means that across the way, this also has to be 82.5 feet. So we're going to set up a function to figure out what this angle is if two of the sides are 800 and 82.5 from our picture so far. So this is opposite and adjacent sides. So first I would set up a function that's tangent of theta would be equal to 82.5 divided by 800. So a pretty small number there, about a tenth, or about 0.1 approximately. So now I'm going to rearrange this into the inverse tangent of that fraction. So we're taking our output and putting in as our input in this situation. And our normal input of a degree measurement is going to be our output. So a reminder on how we can do inverse trigonometry. The steps will be pushing secant and then tangent to get tan inverse. And then we just type in our opposite and adjacent side lengths as a fraction. And if we press enter, we get about 5.88. So we could say our answer is about 6 degrees for our angle of depression. With a boat that far out, that makes sense that your eyes wouldn't be that many degrees down from where you'd be looking out into the horizon straight ahead in order to see a boat that is 800 feet away, almost 3 football fields. And that concludes a word problem where we're using trigonometric inverse, where you have your comparison of two sides as a ratio as your input instead of the normally being your output. And then your answer in this case was your theta, or angle, being about 6 degrees. We now move on to our last problem now that we have finished up problem 4. So if you haven't, make sure you pause the video here to take down this example in your notes. And we will finish up with a problem like this one here. So we are going to be looking for some different things here. So we can underline the important stuff. So they're building a skateboarding ramp, and the ramp must be set up to have a 30-degree angle of elevation. The platform of the ramp is 8 feet long. And we want to figure out how far is the base of the ramp from the platform. And so we're going to kind of draw our picture now. So we start off with our right triangle, obviously, and we're going to have a 30-degree angle of elevation. So we're building this on top of a platform, and you have to make sure we're careful with what's the ramp and what's the platform. It also asks like what the length is required for the ramp. So we don't know the ramp length. How far is the base of the ramp from the platform? Our platform that they're talking about, I think they're talking about this far side being 8 feet. And then they're also talking about how far is the base of the ramp from the platform. So they're also asking about this y value right here. And so we can now basically we're going to be solving for two parts of this right triangle. And we can look at it as the two steps of doing that. So first, we're going to look for x. So x would be using the sine of 30 degrees being equal to 8 over x. So we would multiply by x on both sides. So that would give us x times sine of 30 equal to 8. And then you would divide by sine of 30 on both sides. And that would give you x is equal to 8 over the sine of 30. And so we can grab our calculator to get that answer. 8 divided by the sine of 30 degrees is equal to 16 feet. And that 16 feet is the answer to x. So we could do this by using trig, like you said, but you'll notice that our 30 degrees right here, that means that this top one is 60 degrees. And you'll notice that 8 and 16, that's double for our hypotenuse side. So you might recognize this as a 30, 60, 90 special right triangle, in that our hypotenuse side is 2a, our 30 degree side is a, and our 60 degree side is equal to a times the square root of 3. And all we have to do here is, well, if I know that my a is 8, I can know that 8 times the square root of 3 is equal to y. And I know that 16 is right by being able to do double what our a value is. And that saves us from having to do trigonometry if you can realize that from the start. But sometimes if you don't realize it until you're part of the way through the problem, you can save yourself time at the end by doing your last step using special right triangles. And that completes example number 5. Overall, we've looked at one example each for angle of depression and angle of elevation. We've explored how to solve both of those, including a second example of one of them as well, where it doesn't mention angle of elevation or depression in it. We've also done a word problem where you were solving for the missing angle in a triangle. And lastly, we did a word problem where you could use special right triangles to solve for your answer. And that concludes our video lesson on trigonometry word problems that require drawing a diagram in order to solve the problem. It is always a good idea to draw these diagrams so you can avoid mistakes. And with that, we will conclude our video. Thank you for watching.